Now I actually wanted to move focus on the next slide to what I call as the cost pillar. Now taking a similar study was actually done again, taking data from the research I just mentioned now, and using a hypothetical cost to a product development organization of 100 engineers, assuming that the annual cost per engineer is $150K. There was some detailed study done in the breakup of tasks which these engineers actually did most of their times. So the predominant and impact analysis and coverage. So I'll just spend a few minutes trying to explain what this search means. So this search actually covers both simple text searches across the distributed data sources, which they would be using for the engineering. For example, text searches against their requirement gathering tool, text searches against their defect repository, text searches against their test case repository, test searches against their source code control tool, text searches against their modeling tool, their work item tool, their project planning tool, just trying to search. And it also covers complex searches. For example, find all the requirements and test cases and work items and design elements that include the term, say, handset. Or for that matter, deriving from an earlier example, a complex query like how many requirements for the heart pulse monitor are related to the tests that fail on the last execution run. So these are sort of searches which typically people are trying to achieve from their engineering data. And that is supposed to take around 15% of their time. The second bullet is on how creating documents. Actually, this talks about how we try to pull together integrated reports from multiple sources. All our sources together. Might be it's a traceability report. It could be a coverage report. It could be an impact analysis report. It could be a safety report. It could be a compliance report. And to pull out data for creating such reports, we need to actually look at multiple sources. The multiple sources which actually store and manage and provide a life cycle to various components of your development life cycle, not only for software, for your systems as well as hardware. That is supposed to take around 5% of the time, and 5% of the time as well as a dollar number to that. The third and important aspect is about impact and coverage analysis. Impact and coverage analysis is like picking a focus point, say a particular artifact, and seeing all its relation to other artifacts in order to determine the impact of a change to that artifact which you have focused, or to check that there are relationships to other artifacts to verify coverage. For example, does the requirement have a related test case associated to it, or does if I change a particular requirement, what test cases would need to be changed, what design elements need to be changed, what of course are the hardware changes, what of course are the software code changes. So it's very important to stress that the impact here, even though it is being quantified, the impact can be far greater than the quantified costs on the slide. Actually, missed information in actually searching impacts a lot. For example, we need to change some properties of a number of requirements for response time of various systems functions. So we search, but we don't find them all, and so we miss changing the response time for a particular function. Now, hardware and software is designed and implemented, the system is delivered, and then function responds outside the parameters we really wanted. So this would result in a high cost of rework, or even product recalls, which we have seen a lot in the industry. Similarly, if an area of the product is missed when performing what we call as impact analysis, then the cost and effort of implementing a change request may be incorrectly assessed, and worse still, the change request may not have been fully implemented at all, again leading to rework costs, possibly leading to late delivery, and again worse, leading to product recalls. Basically, the resulting costs can be pretty huge. So what's really needed is a way to enable engineering teams to focus more on the core engineering work and spend less time and effort in dealing with complexity and rework. We actually have to restore the balance and help engineering teams to work faster with higher quality by improving their development processes and asking the tools to do more, right? So basically we need a next generation approach to both the processes and the applications or tools that support these processes. So with this context in place, I would like to take this discussion to the next part, and this part talks about how we are all working as in smarter teams, working on smarter products which have not been developed the same old way. So this is sort of the third pillar or the third challenge which most of us are actually facing. So traditional product development was sort of linear, like 10 years before today. The product development was linear. When I say linear, I mean it was led by basically physical and mechanical engineering disciplines, if I could use that term, and with teams in one place and with sort of limited upfront planning. But actually the development of the next generation of products and systems demands a sort of a top-down holistic approach, and most of these places it's the software which is driving the innovation. And since most of the places it's the software which drives the innovation, these products must be actually developed seeing how the software and systems interact with all the other areas upfront, sometimes even before development begins. So basically, software is no longer secondary, actually. It is actually upfront. Thus, a systems engineering approach is sort of becoming encore and in focus rather than trying to do a traditional physical bill of materials based approach, and rather view it as a bottoms up assembly of parts. So basically the solution here is to look at it as a top down holistic and a domain integrated approach rather than a bottoms up assembly of parts. So definitely all of us are working on next generation products, and hence a next generation approach is needed. So having discussed the implications of complexity, the implications of the complexity of engineering data across the three pillars of time, cost, and traditional way as well as the current way of working, I would now focus on the next part of the presentation, which is to understand how we propose to solve this problem. So all of us have actually worked in organizations wherein we must be having lot of data across various activities which we do in developing systems and software projects. For example, we must be using a particular tool from a particular vendor for requirements. For planning, we might be using a different vendor or the same vendor, a different tool. We might be dealing with electronic and electrical components. Of course, most of us deal with source code. A few of us also deal with mechanical parts. Predominantly all of us need a way to manage documentation. And so we have understanding that traditionally much of the data that we created and managed during this entire life cycle of the systems and software projects is actually not open data. Historically, this data has only been available to users of the tool that manages that data. You might be using a tool to manage your requirements, and that data, those requirements historically may have been only available to the users of the tools of that requirement tool and to manage that data. So in such closed environments, we are actually prevented from answering complex questions that actually rely on our understanding of the relationships between the data managed by the different tools. For example, the requirements which are linked to the test cases, or the requirements linked to the models, and the models which are linked to the test cases, and the test cases which are linked to a particular source code. So a closed environment, and we are sort of prevented from answering complex questions. Furthermore, many times the tools in such closed environments have less common understanding of the types of data and relationships that they are trying to manage of the other tool. So I agree, the problem is not new, and this has been attempted to be addressed in several different ways in the past. For example, using a single repository has been a way to manage all this data, but pretty much it has turned out to be sort of unrealistic, since it implies that a single vendor is required. A single vendor needs to be made sure that he or the vendor understands the entire spectrum of this data. And what happens is this prevents the adoption of the sort of the best of breed solutions, and it becomes a pain of integrating of data that companies have in their existing repositories. It's simply not practical also to migrate all your data. I want to introduce a term here, all your life cycle data into a single monolithic repository. First of all, we might be having terabytes and petabytes of such data, and such repositories have actually huge operational challenges with their performance sizes, their upgrades, and their backup. So this has been traditionally a failed approach, wherein we try to look at it as a single repository problem. The next stage of evolution was the sort of the point-to-point integration between multiple tools. That has resulted in something which has taken us to the next level of challenges. It did help solve the challenges which happened with the single repository approach, with the point-to-point integration approach, but the point-to-point integration sort of proved to be brittle most of the times, and also prone to breaking when the tool versions are sort of updated. In the hardware, in the electrical and electronic industry, there has been a lot of focus on trying to build up universal metadata standards. History has showed us that there has been a 50% success here, and predominantly sometimes due to conflicting priorities and motivations between multiple vendors, and coupled with the fact that the standards were sort of very rigid and were not providing any flexibility for the individual teams to customize, that approach has also not sort of kicked in, if I could use the word. So traditionally, a single repository approach to actually find a repository which can be